Welcome to this video on the top 30 JavaScript interview questions for 2026. Whether you are a beginner or looking to sharpen your full-stack development skills, this guide covers the core concepts essential for your next big interview. Here is the roadmap for what we will cover today. We will move through JavaScript fundamentals, execution context, closures, async programming, performance, and finally, system design. First, let's compare variable declarations, var, let, and const. Remember that var is function scoped and hoisted, whereas let and const are block scoped. Always prefer const for fixed values. Question 2. What is hoisting? Hoisting is the behavior where declarations are moved to the top of their scope during the creation phase. It's crucial to understand how this impacts your code execution. Question 3. What is the temporal dead zone? This is the period between entering a scope and the initialization of a variable declared with let or const. Accessing these variables before initialization results in a reference error. Question 5. Explain the scope chain. JavaScript searches for variables starting from the local scope and moves outward through parent scopes until it reaches the global scope. What are closures? A closure occurs when a function retains access to variables from its lexical scope even after the parent function has finished executing. They are essential for tasks like caching and private variables. Question 6. Explain the execution context. This is the environment where your code actually runs. It includes the variable environment, the scope chain, and the this keyword. Question 7. What is the call stack? It is a stack data structure that tracks function execution order. When a function is called, it is pushed onto the stack. When it returns, it is popped off. Question 8. Explain the event loop. The event loop continuously monitors the call stack. If the stack is empty, it takes callbacks from the queues and pushes them for execution. Question 9. Microtask versus macrotask. Remember that microtasks, like promises, have higher priority and must be cleared before the engine moves to any macro tasks like set timeouts. Question 10. What are promises? They represent the eventual success or failure of an asynchronous operation. They exist in one of three states: pending, fulfilled, or rejected. Question 11. Promise.all versus promise.all settled. Promise.all fails fast if any promise rejects, whereas all settled waits for all promises to finish and provides their individual outcomes. Question 12. Async await. This syntax is syntactic sugar that simplifies working with promises, making asynchronous code look and behave more like synchronous code. Question 13. The prototype chain. JavaScript uses prototype-based inheritance, meaning objects can inherit properties and methods from other objects through a chain that eventually ends at null. Moving to question 14. The call stack. Its primary job is to track function execution, maintaining the order of operations as functions are called and returned. Question 15 covers the difference between call, apply, and bind. Call and apply execute a function immediately with specific arguments, while bind returns a new function with the context already set. Question 16 focuses on the advantages of arrow functions. They provide shorter syntax, possess a lexical this context, and make functional chaining in operations like map and filter much cleaner. Question 17 is about destructuring. This powerful feature allows you to unpack values from arrays or properties from objects directly into distinct variables, greatly simplifying your code. Question 18. Spread versus rest operators. Remember this simple rule. Spread expands iterables into elements, while rest collects multiple elements into a single array. They use the same syntax, but act differently. Question 19. Deep versus shallow copy. A shallow copy references top-level properties, while a deep copy, often handled by structured clone, creates an entirely independent clone of the object and its nested children. Question 20. Map versus weak map. Map holds strong references, whereas weak map holds weak references, allowing for better garbage collection when keys are no longer needed elsewhere in your app. Question 21. Set versus weak set. Similarly, a set stores unique values of any type, while a weak set stores only objects. Using weak set is a great strategy for preventing memory leaks when tagging objects. Question 22. Debouncing. This performance technique ensures a function only executes after a specified period of inactivity. It's essential for search boxes to avoid making unnecessary API calls. Question 23. Throttling. Unlike debouncing, throttling guarantees a function is called at most once within a set time interval. This is perfect for high-frequency events, like window resizing or scrolling. Question 24. ES modules. These provide a standard for code sharing. You can use static imports for dependencies or dynamic imports to lazy load code, which significantly improves your application's initial load time. Question 25. Memory leak causes. Be mindful of forgotten event listeners, dangling timers, unintended closures, or accidental global variables, as these are common culprits that can crash a user's browser. Question 26. Event delegation. By attaching one listener to a parent, you can efficiently manage events for many child elements. This takes advantage of event bubbling and keeps your code scalable. Question 27. Function currying. This technique transforms a function that takes multiple arguments into a chain of functions that take single arguments. It's excellent for reusability and function composition. Finally, question 28. Pure functions. A pure function is deterministic and has no side effects, meaning it doesn't modify external state. They are easier to test, debug, and memoize for better performance. Moving on to question 29. JavaScript engine internals. Engines like V8 parse your code into an abstract syntax tree, or AST. This tree is then converted into bytecode, which is executed and optimized using a just-in-time compiler for high-performance machine code. Question 30. Real-time notification architecture. Scalable systems rely on WebSocket servers for bidirectional communication, often combined with a message broker like Redis or Kafka, to manage event delivery across multiple server instances. We have covered the top 30 concepts. Keep this cheat sheet handy as you prepare. Remember, for senior roles, focus on the why. Deep diving into performance optimizations and architectural patterns will set you apart. Thank you for watching. If you want a PDF copy of these notes, comment JavaScript below. Don't forget to subscribe for our upcoming series on React, Spring Boot, and system design. Keep building and keep learning.